Hi, welcome back to Math 111. I want to talk with you just a little bit today about quadratic functions. So, in this chapter, what have we done so far? We've done linear functions, we did absolute value. Today we're going to do quadratic, and this is going to be kind of a lightning-paced review of quadratic functions. We're going to most likely, I'm pretty sure, come back to these later in the term, but for now we're just going to look at their graphs. So a quadratic function is one that has the form, or can be written in the form, f of x equals ax squared plus bx plus c. So the diagnostic here is the 2 on the exponent. The exponent of 2 tells you you've got a quadratic function. Quadratic functions are pretty slick. Their domains are all real numbers. We can graph these. We're going to find their zeros, and we're going to find their zeros pretty quick and dirty from the graph. You'll remember from previous classes that sometimes finding the zeros of quadratic functions can be tricky, and we will spend more time with those later when we start talking about solving equations and not just graphing. And we'll also refresh ourselves on the quadratic equation here in a little bit. So let's just take a look at these. Remember also that not all quadratic functions are going to have zeros. We'll talk about that. And notice this here. What does this look like? So let's graph this second one. The first one's kind of boring. Let's graph the second one here. What's this look like? Well, it looks like, I'll tell you what I see. Hopefully you see the same thing. I see a vertical shift of 1, a horizontal shift of 3 towards the, positive x-axis, and a reflection and a vertical stretch of 2. It's going to be steeper than a standard parabola. Let's use Desmos here. And let's just pop that in there. G of x equals -2 times x minus 3 squared plus 1. Whoops. I've got an extra x in there. That's better. That's what I was expecting to see. So we'll talk later in this presentation about how to find in actually just a couple of minutes, about how to find the vertex, this guy right here, without the graph. But for now, we can see we've got a vertex at 3, 1 and zeros at, funky number, 2.239, huh? Or 2.293 and 3.701. Let's talk about how we would find those algebraically. It's not too hard because this equation is in a nice form. So let's find the zeros. What the zeros mean, notice that the zeros are where we cross the x-axis. That means y equals 0, right? So what we're actually going to be doing here is we're going to solve the equation 0 equals -2 times x minus 3 squared plus 1. We want to isolate the squared terms. Let's subtract 1 from both sides. Divide through by -2. And we get 1/2 equals x minus 3 squared. Take the square root of both sides. And remember to take the positive and negative square root. Add 3 to both sides. And we get x equals 3 plus or minus the square root of 1/2, which is the exact mathematical representation of 2.293, and 3.707. So the 0.707 is the square root of 1/2. 3 plus the square root of 1/2 is about 3.707. 3 minus the square root of 1/2 is about 2.293. Not too bad. Hopefully this algebra wasn't too much of a stretch. It's pretty simple. Okay. This should be within your means at this point. If it's not, we may need to do some review. So come see me if you struggled with this set of algebraic steps. Okay, so domain, positive, negative, infinity. The range, well, we can get that from the graph, yes? The range is 3 is the maximum. So it is negative infinity, oops, sorry, 1. Range is the y's. Negative infinity to 1 is the range. Increasing from negative infinity up to an x of 3. Decreasing from x to positive infinity. Relative and extreme. Maximum at y equals 1 at the point 3, 1. Okay? Parabolas are nice. They behave nice and predictably, and we like them. They explain a lot in the world. So there's our graphs of our two functions, just like we saw and just as we expected. Yes. This is just illustrating points that you could plot. All right, so we know some stuff about parabolas. We know, or quadratic functions. We know the graph of y equals ax squared plus b, y equals ax squared plus bx plus c, where those are all real numbers, and a is not 0. If a is 0, we don't have a quadratic function, right? Makes a parabola, yes? If a is positive, if our leading coefficient is positive, parabola opens upwards, and our vertex is a minimum. If a is negative, if our leading coefficient is negative, then our parabola opens downward and our vertex is a maximum. Now, one thing we do want to talk about is the line of symmetry. So you see this dashed line right here, this guy? The parabola is symmetrical about that vertical line that goes through the vertex. The equation of that vertical line is going to be x equals whatever the x-coordinate of the vertex is. And we can find that vertex from the equation. And we'll see parabolas in two basic forms. We already saw this. We'll see parabolas in an a times x minus h squared plus k. This is the standard form. And if we see our parabola, our equation in this form, we can find our vertex from the coordinates h, k. The only tricky part about this is it is always x minus h. So if this were, say, we'll look at an example. Just remember your standard form is a times x minus h plus k. H gives you the x-coordinate of your vertex. K gives you the y-coordinate. Again, this should look familiar. You should be able to think of this as a series of transformations. The H is a horizontal shift. The K is a vertical shift. If you think of this in terms of transformations, you'll always get this correct. Now we can also find quadratic functions in the ax squared plus bx plus c, what we call the general form. And in this case, we can find the vertex from the coefficients of our equation. The x-coordinate of the vertex can be found by taking the middle coefficient, b, changing its sign, and dividing it with 2 times the leading coefficient, or we can say negative b over 2a. That is the x-coordinate of the vertex. We find the y-coordinate by just plugging that x back into our function. So let's practice. Let's find the vertex of the function f of x equals x squared minus 4x plus 3. f of x equals, what do we say? X squared minus 4x plus 3. Yeah? We want to find the vertex. This is in general form, so we know that the x-coordinate of the vertex is at negative b over 2a. b is negative 4, so it's going to be the negative of negative 4 divided by 2 times a. A is the leading coefficient. In this case, that's going to be 1. So that's going to be the negative of negative 4, which is 4, divided by 2 times 1, which is 2. Okay, that's the x-coordinate. How do I find the y part? Well, I plug it back in. 2 squared minus 4 times 2 plus 3. 4 minus 8 plus 3. 4 minus 8 is negative 4 plus 3 is negative 1. So my vertex is at the point 2, negative 1. Not too bad, right? Let's try the other one. The other one says find the vertex of g of x equals negative 2 times x minus 3 squared plus 1. G of x equals negative 2 times x minus 3 squared plus 1. Let's make sure I got that right. Negative 2 times x minus 3 squared plus 1. Yes. Okay, this is in standard form. So this is in a times x minus h squared plus k form. My vertex is at hk. In this case, 3, 1. Now, a minute ago, I said things might get a little tricky with this. Let's look at, suppose I've got j of x equals 7 times x plus 2 squared minus 4. What's the vertex? Well, remember, it's always x minus h. So this plus 2 is actually x minus a negative 2. So my vertex is at negative 2, and then plus k, so this minus 4 is plus a negative 4. So it's negative 2, negative 4. Just have to keep your positives and negatives straight on these. Okay? All right. So I told you we would revisit the quadratic formula. Remember that one a minute earlier in the day where we were finding its, this one. Oh, we worked with this, so this one where we found its zeros and they were funky numbers, and I solved that equation by isolating the quadratic or the squared term, taking the square roots. You can also use the quadratic formula to carry out that operation. You just have to make sure that your formula, your quadratic function, is in general form, and that means ax squared plus bx plus c, and is set equal to 0. If you do that, then you can find the x for which that will be true by using this quadratic formula. Now, this is something that if you want to use it, you need to memorize it. There are a variety of YouTube videos out there that can help you with this, but if you want one that will stick in your head, Google quadratic formula song, and my favorite is set to Pop Goes the Weasel. I'm going to make the leap that at this point we know how to use the quadratic formula, but we will practice this when we get together. What we do is we put our quadratic function in general form, and then we note down the coefficients A, B, and C. We can find the x values that will make this equation true by plugging in B and A and C into the appropriate spot. And to this day, when I use the quadratic formula, I say to myself as I'm writing it down, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I will write it down this way before I plug in any numbers. Okay? Memorize this. It can be your friend. It is your friend. Memorize it. And we're going to take a look at a specific part of this function, or this formula right now. We'll spend some more time with this later too, but we're going to look at just this bit right here. This bit gives us so much information that it actually has a name. Its name is the discriminant. Okay, so if we've got and it tells us a lot about the types of solutions we'll see for this function, the types of zeros we'll see. So put your quadratic function in general form, ax squared plus bx plus c equals 0. Look at just b squared minus 4ac. We call this the discriminant, and there's a trichotomy around this discriminant. That trichotomy tells us that if we know what the discriminant is, we will know something about our quadratic function, and we'll also know something about its graph. So if this b squared minus 4ac is a negative number, that means, if we think about it in terms of our quadratic formula, that means that the thing under the radical is negative. So if b squared minus 4ac is negative, that means that there's no real numbers coming out of this, because if this is a negative number, the square root is an imaginary number, and all of our roots will be complex. So if b squared minus 4ac is a negative number, that means that this equation, ax squared plus bx plus c, has no solutions. What that means for us in terms of graphing is that our parabola will not cross the x-axis, because the solutions to this equations are the zeros, or the x-intercepts. Okay? So we care about the discriminant because it tells us whether or not we're going to have any x-intercepts in our graph. If this discriminant equals 0, then this equation has exactly one real solution. Or for graphing, what that means is that our function has exactly one x-intercept. The only way that happens is if the vertex is on the x-axis somewhere. If our discriminant is positive, that means that our parabola has exactly two x-intercepts and crosses the x-axis twice. So we care about this thing because it gives us hints about what our graph's going to look like. So let's take an example. Let's go back to our Port-A-Boy gaming system. And we know the weekly revenue. We found this earlier in the week. Weekly revenue is given by negative 1.5 times x squared plus 250x. The cost, we also know this function is, the cost function is 80x plus 150. And we're going to look at the profit. Now, the profit function is given by the revenue minus the cost. So let's start with that. My revenue function, this is the amount of cash I get in my cash drawer at the end of the week. It's negative 1.25, maybe. No, 1.5. I knew that wasn't right. Negative 1.5 x squared plus 250x. And remember, x is the weekly sales, so x is the number of gaming systems we sell in a week. The cost function is 80x plus 150. So this is the amount of money I have to lay out to make these gaming systems. This is the amount of money I get to put into my cash drawer. The profit, which is the amount of money that goes into my bank account, is the revenue minus the cost. So this is how much I actually make. So that's going to be negative 1.5 times x squared plus 250 x minus 80x plus 150. We're going to do a little arithmetic here. And my profit function is going to be negative 1.5 times x squared plus 170x minus 150. Be careful with that negative sign. Okay, make sure you distribute it through correctly. So this is my profit function. Now, what shape is that going to make if I graph it? Yeah, it's going to make a parabola, right? And specifically, it's going to make a parabola that opens down. So what's that tell us? It tells us that there's a maximum. This function looks something like this. And if these are dollars and these are sales, so this is not just dollars, this is actually price, right? That's price per unit, and this is number sold. So there is a price where I can maximize my profit. So I can figure out what price I should sell these things for in order to maximize my profit. One second. Okay, I will call that person back. So let's find that. That point is called what? The vertex, right? So this is, what is this? This is number sold. And this is profit. So let's figure out the number sold that will maximize my profit. That's at the vertex. Which we can find from negative b over 2a, right? So x is negative 170 over 2 times negative 1.5, or, let's pull out my calculator, negative 170 divided by parentheses 2 times negative 1.5. I could have just put in 3. 56.67. So, do we want to say 56 or 57? Probably 56, because so think about it this way. If this is my vertex, 56 is on this side, 57 is on that side. So probably 56. So if we sell 56 units, that is my maximum profit. Okay? How do I set the price? How do I sell 56 units? Well, let's look back up here. Remember that we've got a price function. The price function is negative 1.5x plus 250. We can do this. So my price function is negative 1.5 times x, whoops, sorry, that's p of x, plus 250. I want to sell 56 units, so I should price them at let's figure this out. So take negative 1.5 times 56 and add 250 to that. And we get $166. So the price that we should set these things at, we should sell them for $166 each. That will target a sales amount of 56 units, which will maximize my profit. See? Math is useful. Huh? Okay. Only one more slide here, which is this one. So let's take a look at, and it's right here, the graph of x squared minus x minus 6. This parabola represents just the inside, the x squared minus x minus 6. But look here, we've got a composition. This is an example of a composition of functions. We've got a function inside, so this is a function inside something else, in this case an absolute value. So think about the graph and then think about what the absolute value does to what's inside. It's going to take this whole negative part, this guy right here, all of this, and make it be positive. And this turns out to be our graph. Okay, so we will talk some more about these things when we get together again. Bring any questions you might have. Try to take a look at some of this homework and the textbook section before we gather. Have a great day.